Wait, didn't I already have a ship crew? Where are you headed to? Well, if you, I mean, you don't have to answer that. Obviously, it's up to you. Okay, so ship crew is different, which is good. US or Israel? They're two interesting choices. I've never been to Israel. I think it would be cool to go. I don't know that I'll ever go there though. Just because it's, you know, hard to go everywhere in the world. Oh, nice. Okay, so it should be pretty easy for you to go to either of those places then, I take it, and naturalize the other one if you stay there for long enough time. I don't know how long it would take for that to happen, because I guess you would have to, well, no, if your wife is a US citizen, then it should be easy enough. I don't know how long it would take her to naturalize you, or whatever the right term is. I like it. Yeah. I don't know how that works exactly for married folks, but hey, Chexer as well. How are you? Conscripts. All right. Yeah, redeem some Cairo points. Force me to drink more water. Or make me do something really hard, but I won't do it today. 13,000. My goodness. Yeah, I think there's potentially some interesting ones in there. Like you can make me drink water, which is good for me, obviously. I don't even remember what else you can do. Is that whale built in? Nice, that's sweet. Oh, you just use the whale emoji. Yeah, we got like highlight your message, which is lame, but I put it there. I made one so you could modify the emotes because I wanted people to have access to the emotes no matter what. Like I don't want you to not be able to use them. And then for 10,000, it's like you can ask me to explore a Haskell library. So that was the idea, and we'll see how long that lasts. But that's kind of the goal. All right, so we need to make some lenses for ship crew. Yeah, you got 13,000, so we might be exploring a lot of Haskell libraries. I thought that would be a good thing. Like it might be fun for, yeah, or you can maybe drink a ton of water. And I'll get up and go get some. I suppose we can turn drinking water into like it doesn't have. It just says hydrate. To be fair, so like I could go get a bourbon or something. You guys could get me drunk sometime. I don't know if I'm allowed to say that on stream. I should probably check that out. Okay. So our task is, given a ship crew, list out every crew member's name. List out every crew member's name. Well, there's only one name. Okay, our ship crew structure is unfortunately not foldable, right? Like we can't. Oh, I guess this is captain. All right, so conscripts imply. Okay, I get it. So there's the ship name, there's the captain, the first mate, and the people working on the ship. That's the idea. What does the word conscripts mean? I should probably know this. Oh, okay, so it's specific. All right. I don't know that I've ever heard that term before. I mean, probably have heard it before, but not made the right connections clearly in my brain. Okay, So our ship crew structure is unfortunately not foldable since there's no type parameter. If we want to list our whole crew, we'll need to find some other way. To make things even trickier, yeah, the first mate and captain are sort of special. How can we focus every crew member's name from this weird layout? I suppose we could make a getter that does that, right? When working with lenses, we had the lens helper, which allowed us to define arbitrary lenses. The equivalent folder helper, blah. The equivalent helper for folds is called folding. Interesting. So we have a S to FA, right? So this is where we embed the F, and that's how we get, I guess we can do the folds, right? Because we're basically embedding something that's foldable. Sure. The projection function. Okay, so collect crew members, ship crew name. So we want to take, what is the, I think it's this. I think this is the right syntax, but I forget what these things are called. Oh, I wrote the wrong thing. Ship crew. Can you hear my cat? He's pretty loud. And then this should give me another error. Record wildcards. For sure. Yeah, give me a second. We'll start at the top. It should be easier. I just want to see if I can get this to compile first. What is this complaining about? I don't know why this would complain. Let's just reopen it and see if that jogs its memory. Okay, so it seems okay now. All right, so lenses basically are sort of the traditional lenses that, not traditional, that's not the right term. The simple lenses basically provide you two things. They provide you with a getter, like to get a name, for example, from this crew member, or a setter. So how do you want to set this name? And then using the getter or setter, you can do more complicated things. So for example, you could change the name to something else, that's the setter, but you could also apply a function to with the setter. So you could say like, I'm gonna, this is a string, so I want to concatenate, I don't know, or I want to prefix doctor to their name, something like that. You can use this over function. Here, I'll bring it up in Google. Over lens, which basically looks like that. It's gonna take a second for it to load up there. I should probably have the local Hugo running. It'd be a lot easier. But you have this function that takes a setter, so that's the lens that's required to do a some set operation. You take a function like a to b, so just modifying a simple a to b. You take an s, which stands for structure. So this is like the structure before you apply the lens operation. And then t stands for the structure after you apply. So this is like the value before, the value after, the structure before, the structure after. And basically this is kind of what a lot of the things that we've talked about so far look like, something like this. And then there's more traditional getters and setters for these things as well. And I think, so this chapter was all about folds. So let me open up the chapter 5 stuff real quick. So in chapter 5, what we did was, it was all about operators. So like, for example, we have this A thing right here. So this symbol, this infix operator, stands for over. So here's an example of over. So first, we build a lens. So this lens takes this payload, and reaches in. So it's like focusing on this element. So that's the term is focus. And then we focus further by looking here. So we're looking specifically for this A. So that's our focus. And then what we do is we modify it with show. So in this case, we start with a ship of integer, and A here is just the type. And we have a function A to B, right? We're just turning int to a string. So this is how this looks. So this whole thing was about the operators themselves, this whole chapter. This one is a setter. So you can take, this literally stands for set, and then you can take the ship of A and just insert a string, something like this. So there's a set operation. And then this one looks a little funny because I did it in point-free notation, but this would be a view. So this is the view operator. So we do the same thing. We payload weight kilos, and we view the result of that lens, and you get basically the focus A out of it. So this is kind of like basic input and output for a lens. Why is the return type in for this one? Because I put arbitrarily 10,000 as a string in there. I could have put anything in there. I could have put an integer. I could put whatever. It doesn't matter. It's just that in this particular case, I put string because we were messing around. This actually wasn't written in the book. These A, B, C, and actually maybe D as well. I'm unsure. But it was me just messing around with the operators, basically. Does that answer your question? I think so. Yeah, and then this one is kind of the similar thing. So this is what I was saying before. We have this over function with some change. So what we're doing is taking a ship of integer, or we're creating a ship of integer by taking Serenity, which is just a ship, and then adding 10,000 to its already 50,000 payload, or weight. What is it? Yeah, weight in kilos. So that's kind of what that looks like. And then there's like even more interesting operators that you get out of here. And we were talking last time about whether or not they're super useful all the time. And like there are clearly cases where it would be more readable to use the operators themselves. Wait, so your optic type, where? Okay, so I think we're looking at this one still. So your optic type defines ship string when it's set. So what is the return when it get? So if I create, let's say I used B, right, on a ship, any ship, I would end up with that ship where this value was set. And then if I get it back, I would get a string. So this will always be a ship string after it's applied to any other ship. So here, let me just open the REPL. I think I understand what you're getting at. I hope. So if I open up the REPL, I should have this ship called Serenity, and I can change the ship, and I can show you the type. No, what am I doing? Type Serenity, and you'll see it's a ship int, right? If I take B, and then, again, let me show you the type of B. What is it? Expecting something with a unit. Which part would have unit? I guess I don't understand. I'm not. It's expecting something with set. I'm not following, I'm sorry. I wish I was following. Oh, I wasn't done with that. Oh, I see what you're saying. Yeah, so this, okay, I understand. This isn't like a state, right? When we return unit, we're usually thinking about something like state. So like you're putting something somewhere, and you're like modifying the state. But in this particular case, we're not actually modifying the state or anything. We're returning a new object. So lenses, sort of traditional lenses, the way we're using them in chapter 5 is all about modifying data. So finding a convenient way to change values inside complicated data structures. So that you know, the amount of knowledge that we have thus far about lenses at this point, I mean I don't know anything other than this, is, you know, simple getters and setters at this point. And then there's sort of the complicated functions that you can use alongside the getters and setters to do interesting things. Does that make sense? I think I understand where you're coming from. What's up, Ethanol? How are you? Okay, cool. So like there's these interesting operators that you kind of have to understand, and I'm not sure I could explain them again, but I think I wrote it down actually. I didn't write it down. But anyway, like these are really interesting pieces of code that you can write with lenses and accomplish, you know, pretty complicated changes in not a lot of code. So is this human readable? Arguable, but you can do it. Cardiff Russell. Should I feel like I recognize that name, but I don't know where it is, so I want to look it up. Cardiff Russell University in the UK. Oh, wow. Wonderful. Congratulations. That's awesome. Where am I now? Oh, okay, I'm in the wrong chapter. 6. What do you, yeah, that's awesome. What are you doing the master's in? Like, I know it's computer science, but do you have a more specific thesis idea or anything like that? I don't really know how master's programs work in computer science in the UK, because I just assume that it's different than the US, and I don't even know how they do it in the US. So, right. Okay, I think we were talking about that before, right? That you were really interested in that stuff. I vaguely remember that, but I'm pretty forgetful. All right, so what were we doing now? Right, so we're creating like a function to collect the crew members. And so this is one option. I think that I would prefer if we did ship name, not ship name, captain, first mate, conscripts. That should compile, I believe. It involves mandatory Java, Python, and other curriculum, then optional modules like distributed computing, computational systems, computer vision. Cool. Yeah, that sounds really fun. Minus the Java, I guess, but I don't know a lot about Java because I didn't have to do I didn't do CS in school. So not that that's true for every school, but I know a lot of schools use Java as their first language name. Okay, so there's this function which we can create custom folds by folding the collect crew members function. That's cool. What's the issue here? What is it complaining about? Oh, okay. Let's just put a prime here. Crew members fold. Call it that. Plan his PhD afterwards. Become a researcher or work at a university. Yeah, that's what I do. It's pretty fun. Not the best pay in the world, but the benefits are great. I don't know if that's true in the UK, but I hope so. All right, so we need a function that looks like this. that takes the item and returns a list of something. So that's what we need here. So we could just define an f. We don't really need to define a separate function here. We probably could just do something like I don't know what we would call it, but probably like folder. And it would take a ship crew to name list name. Right. So like before when we did this, we defined like get and set a bunch of times. So it probably makes sense to do something like this instead. Like I can't imagine we need collect crew members for anything else. So this is probably maybe better. And I don't really know if there's any benefit to doing this over this. I know that this operator is can be problematic in large lists, but these are pretty tiny lists. I would assume that they're tiny, generally speaking. So there's probably really no performance benefit from doing this, but just how I would look at it, I suppose. All right. If anyone has any comments about that, I would be interested to know. I doubt we would gain anything by doing that. But maybe there's something I don't know. Always open to new information. I don't want to write all of this. Oh, right. What we did last time was put people's names from the chat. So, sorry, Oren. Anyone else want to be? Who wants to be the first mate? Gotta be somebody else, though. So we're waiting on a name. Maybe a few names, actually. If anyone wants to put their name into the bin. Give you a second. All right. What's this? Orc? Okay. Long John Orc. I think there was a whale earlier, so we can say one-eyed whale. And then we'll just, I'll be the filthy one, I guess. And I did this wrong, and to close that. Okay, there's our crew since nobody's talking, which is fine. Like, don't. Totally lurking is cool. All right, and then now we can do things like, what was the last letter that I used? J we need. So J is gonna be a list of name. My crew folding crew members fold. Did anybody see the Haskell Weekly today? I think the Neil Mitchell blog post was out there, which looked interesting. Wait, where's Purple Pearl? Oh, right, that's a ship name, so that's not going to be there. Okay, and then we want to check that this actually works. So, what is it? Alt Enter. Stack REPL. So, since there's a few people watching that are mostly regulars, I should mention that at the end of the month that I'm moving, so I may miss a few streams at the end of the month, but I don't really know how much that will be. But, and also on the end of June, not this month. And next month we also have my 1-year affiliate anniversary, I guess you could call it. And so I still need to figure out what I want to do for that. But I was thinking about just doing a really long stream, like an 8-hour pure script stream or something. That could be fun. All right, so we got, yeah, that makes sense. We just need some kind of function that takes, I guess this is S to B. Well, list of B. I did finish the Elm book. Yeah, I need to post that online as well. There's also another book that I want to do that I got from Manning, so we should do that book as well. And somebody actually recently posted on Twitter that the book is really useful even for folks that already know Haskell, so that's exciting because I thought it was going to be like a only beginner's book, but apparently it's better than that, so that's good. Okay. All right, so apparently there's an opticsy way to get out the strings specifically, and there it is. Okay, so mapping over folds. So we've got a fold which selects many names, but we'd love to modify it to focus on the underlying string. So this is always a terminology, is like you're going to focus on something. So right now we're focusing on the names, and folds behave like queries. So I was Oren was asking about optics before. So when you say a fold, it doesn't reduce like a fold in Haskell. Like fold map, right, makes some kind of reduction. You're not really thinking about folds as a reduction in this case. You think of it kind of like a query. So like we're asking the data structure what names are inside of it, right? For, well, what people are inside of it, because this is also just a name. But then we can take it one step further and map over top of this. I vaguely remember hearing about conf. Okay, well, I'll leave this open and look at it, but that's interesting. I know about Haskell Love as well, so that's another conference I'd like to be a part of, but it's like virtual. I'm not going to do a talk or anything. I wouldn't be qualified to. All right, so we've got a fold. Prefer many small and precise combinators which can be composed in different combinations to solve many different problems. Hey Lumi, how's it going? Look, I haven't seen you in a while, but probably busy. All right. It's much more composable and reusable to write small new optics and chain them together. So in this case, instead of editing to return strings, we'll chain on a new fold to do the unpacking instead. The idea in this case is we want to map over the end of our fold somehow. There's a function exactly for this purpose. So the to helper is pretty simple. Converts a function directly into a fold. All right. To is technically a getter rather than a fold. Okay, so like it behaves like a functor in this particular case. Okay. To get name. Interesting. Okay. Okay, so we could do K be a list of string my crew folding crew members fold dot to get to. two. I'm trying to think about like how do you read this in English? So this is like to list of. It's like my crew to list of the folding function dot to get name. This is hard to read in English, but we could probably come up with a better name for this, I guess. I mean, they just call it crew members. So it's like to list of crew members to get name, something like that. So that wouldn't be so bad to read as a human being. But yeah, so we should check that this actually works. V R K. Great. Lumi, you just missed the chance to get your name in. Sorry. I mean, I guess I could change the code to put you in there if you really wanted to. All right. So combining multiple folds on the same structure. Yeah, in the Hall of Fame. Your name will forever be minted into GitHub, which will end up in a cave in the Arctic. Maybe. I don't know if they're doing that again. Oh, yeah, can do. Water's important. Okay, so combining multiple folds on the same. Oh boy. How many of those do you have? You see, you have like 13,000. This is going to be problematic. I'm going to have to go get more water and pee, obviously. All right. Yeah, you get more, so it'd be impossible for you to use them all. That's the thing I don't understand about this is like, you get too many points to have things that only cost 200. So I don't know what the right amount should be for stuff. I want to make it easy, but I don't want to make it that easy, I guess. But like the other thing is you want to make viewers who haven't come around often able to interact. Right? And like, I don't know. It's tricky, I guess, to get the numbers right. All right. So we're gonna combine different folds. That sounds fun. We can use each of the smaller folds inside a call to folding to build up a bigger fold. Okay. So we have our lenses. Oh, okay, sure, that makes sense. So like crew. Let's change it a little bit to make it a string. Although I guess we just do dot to. Can I do dot to in there? That's what I want to find out. So crew. We'll just call it crew. Well, crew names is fine. Doesn't really matter. So we're gonna fold ship crew string. Then we want to see if we can do crew names folding. Yeah, I agree. We probably want it like this. So S folding captain. It's interesting to me that this is just like a monoidal operation, but I guess we're just making a list of names, so that's not a problem actually. I think what I would rather do is this, but I don't know what is considered the best way. Actually, maybe it's this, assuming my spacing is right. To list of first mate. To list of conscripts. Folded. All right, so we got to think about this a little bit. Oh, and then I think we could do dot to get name. That's kind of what we want to test, if we're allowed to do that. And it looks like we are. Okay. So let's see here. I'm assuming this is compiling. Looks like it. Let me put this back up top. All right, so I got to remember what's going on here. So we have S conscripts, which gives you a list. And doesn't folded return the same thing in this case because it's a list? What if we get rid of this? What does it complain about? Oh, right, we need to flatten. That's what that's basically doing. It's flattening the inner list. Okay, and again, when you think about the return type, you're getting like a list of string. So that's kind of the goal, but the fold takes just the type. Because it's got to, I guess it's got to inject the F. And that's what, well, this is doing, I guess. Okay, well, it seems to compile, which is good. And then we could write L. I don't think this goes along with what he was saying before, but it's not bad. Like, we're making one big combinator instead of small ones. With a single dot? We can try it. Let me just finish this piece. So I think this will be my crew dot crew names. Also, hi CoJames, how are you? So let's think about this. If we put one dot in there, that's just a view function. So it might work. Yeah. Good call, by the way. Yeah, that makes sense because the conscripts is just a list of string. So if all we're doing is doing some kind of folding operation, this should work. Because this is just a list. And all we're doing is trying to return a list of string in this case. Well, this is a list of names and then a list of string. Yeah. Guess it's this way. Yeah, it's this way because you don't see the fingers. Anyway, let's see if it works. Wrong one. So we're on L. That's a semicolon. Yeah, it seems to work. I mean, you don't. If you understand that code right there, you basically understand chapters 1 through 5, more or less. There's some terminology that might be helpful, like structure, focus, these kinds of things. But like if you realize that should be a single dot, that's already enough. You're already better off than me. I forgot to check if the new book contains the error from before. So I need to write this down before I forget. Not the new book, the like the updated version. Because there was a mistake in one of the exercises. I want to make sure to tell Chris about it if it's actually there in the new version. So it does updated version fix. Were they chapter 5 exercises or chapter 6? I think there were 5. Sorry, give me a second. I'm distracted. Yeah, they were these ones, I think. Yeah, these ones. So 6 simple folds exercise. Yeah. Okay. So anyway, CoJames. So you clearly have this idea, like you understand the view functions and the getters and setters, because this is basically just using a getter lens with a view function. That's what this stands for. This stands for toList of, So it's like a view function plus another dot. I don't remember what the, like if the second dot means something specific, but the operator is like to list of. So is like a query along the data structure. Okay. But that's basically it. And folds, again, if I haven't, I think I've already said this, but well, I did already say it, but maybe you haven't heard it yet. It's just like a query. So it's like we're asking for all of the names inside of this data structure. And this is the data structure if you haven't seen it yet. Okay. Exercises. Wonderful. I love exercises. It's my favorite part. Custom folds. So fill in the blank with either to, folded, or folding. So M. You're a wizard, Harry. Famous. It's probably going to be really confusing for other people when they come in here and they're like, what are these partial references? I already did this one. Shoot. Wait, no, I didn't. I've confused two things. Oh, I see. O, P, Q. So I got to put the results in here too. So reverse R. I should probably just copy and paste these, but the copy and paste works a little funny, so. I guess that's 2, but dot underscore a reverse dot underscore. Okay, and then we need to put the answers in here and then fill in the blanks. So you're a wizard, CodeJams. All right, so we have a list. We're saying list of these things to list of folded, which I think returns this same thing, which means this should be also folded. Folded. This is not compiling at all. What did I do wrong? I missed a parenthesis. There we go. I think. What else did I miss? There we go. Okay, cool. So first things first, this one we need to coerce into a string because we have overloaded strings on. Hello? LSP freaking out again, I think. Being very slow. We can use... It seems okay, so I'm a little confused at what's going on here. Let's do... Or maybe... No, it can't just compile. So what's going on here? Hello? Okay, it just compiles it really, really slowly. Okay, this is fine. Because these are just underscore errors. This one is this. Okay. Anyway, so we want to so folding creates a fold. I don't see how we're going to use folding here, or anywhere for that matter. This should be 1, 2, 4, or 5. Interesting. Ah, okay. So I see this. So this is actually folding, I think. Because take 2. There's no hole there. Oh boy. So the LSP here is freaking out because of all these holes. So I think I'm gonna remove them. Oh, I have a function for this. If we do this, then I think it should go a lot faster. All those holes are clearly creating too much work. All right, and then we should see, oh, I already closed that on accident, so stack REPL. Then we should see if these work. So M, perfect. N, perfect. O. So there's only one hole here, but clearly folding doesn't go here. Can this be 2? Yeah, I guess it can. Because this is just like a to B type function. Oh, yeah, careful. Okay, so P is reverse. Oh, but I have this wrong, right? Yeah. So this is actually P. Bob. Oh. Umi. Auto. Anna. If anyone needs me to explain what's going on, please, like, just ask me why you don't understand something, or not why. Ask me what you don't understand, and I'll gladly try and explain it as best as I can. So, like, I'm not an expert at Haskell or anything, but I'm willing to explain or try to explain what's going on. All right. So the goal. Interesting. The goal. Oh, I see. Okay. So these are all, what's the term? I can't remember what the term is for things spelled backwards and forwards the same. Palindrome, thank you. I always forget those kinds of specific names. I have to Google them. But because they're palindromes, we can just use 2, I think. We might need folding, though. I'm not sure. So folding will flatten, so we don't want to flatten. I think we just want 2. Oh, but Lumi is not a palindrome. Sorry, Lumi. So anyway, that's fine. Your name has been messed up. All right, so we want this to be CBAFED. All right, so first things first, we need to turn them to lists. So this is going to be folding, I think. It's not going to, okay, that's fine. And then we want to reverse each of those lists, and then we want to smash them together. I think this is right. All right, so I can explain this a little bit. So this folding function will basically take, will fold over the, sorry, this toListOf function will take this fold and turn this into, I guess, a tuple of list of ABC, list DEF. And then we reverse the lists. This seems incorrect. Now, it must just turn this into this. Folding creates a fold. So let's look at it up here. So here's folding. So this folding function in this particular case takes a ship crew and basically turns it into a list of name after you apply the toListOf. So that's this function here. So it's like if you take toListOf and then a folding function, or a fold, excuse me, you get like a list of something back. So in this case, we're going to have a list of, I'm pretty sure it's just A and B. We can just look at the result here. Yeah, so the type is a little confusing, but I think that this will just be list of car. We might have to, we can do this in the REPL, so hopefully it will be more clear what's going on. But I think it's right, is the point. CBAFED. Yeah, so that's correct. So let's run this and just see what the result is, because this should be enough to do something. Oh, import control lens. Okay, so our intuition is that this should be list of ABC, comma, DEF. Yeah. So it's like a list of list, essentially. List of car. And then we apply the reverse function. So if we use the to function, it basically is like an Fmap over the fold. So it's going to reverse these two lists. So that gives us CBA, FED. And then we use the folded function to remove the outer list. So it's just flattening it. So that's how you end up with CBA, FED. Does that make sense? Hopefully everyone's following. The part that was a little unclear to me was how this behaved, but I guessed and it was approximately correct. And by guessed, I don't really mean guessed. I mean, what do I mean? I'm using my intuition. That's what I mean. Okay, so 1, sort of fill in blanks. with folded, folding, or 2. See pages, well, just page 92. See page 92. Okay. Hopefully this makes sense for everyone so far. But again, feel free to ask questions. You're more than welcome. Okay. So, oops. Fill in the blank with a path of folds, which result in the answer. Avoid Gmap. Okay, what are we on? R. Okay, we'll go one at a time because it was like really, it slowed down my editor quite a lot. So we'll do one at a time instead of, I was hoping to just type it all in and then go through the problems, but we'll do them one at a time. All right, so we want to use a fold function where we basically just map. So I think we can just use 2. Oh wait, we're trying to avoid partial functions. With a path of folds, which results in the specified answer. Question. The mechanics of 2, or more specifically folds, I guess, are a little weird to me, but I think I'll catch on with more examples. Yeah, I'm agreeing with you. It's a little, I'm a little thrown off at the moment. For example, with this one, I'm already thrown off because I would have guessed that like I could have just done 2, times 100. I think. Oh, okay. So this has to be not 2, but folding. Right, because we're using toList of, I think. Do I really need that? I guess I need folded dot folding dot 2. With a path of folds. Is this right? Okay. So it says avoid using partial functions and Fmap. I don't. Oh, maybe. Good call. Oops. Yeah. Yeah, the type of inference didn't matter. Like it was trying to do num, but it couldn't deal with this because we're basically doing toList of, which is embedding list of int. I'm a little confused about this. Avoid partial functions. Although I guess this, I mean, this is not a partial, well, it is a partial function, but I presume that's not what they mean. I want to look at the answer here to see if I'm on the right track. Is everyone okay with that? Or didn't that just show up? Oh, okay. I guess I'm doing different things. What's the difference between this and Fmap? Hang on. He says something about it, but I don't remember reading it very carefully. It just says we could use Fmap over the list of names. So I think it's more or less just to teach you more about like the things you can do with optics in general. Not necessarily that you shouldn't use fold, just that, you know, this is something you could do instead. Yeah. So yes, you could 100% just use Fmap. Like using from just to unwrap the just would be partial instead of using folds. Oh, okay. I can get on board with that. So I should use something like to from just instead of like, well, I guess I don't know if that's the same thing. I'm building a fold, right? This is building a fold. So is that, let's see. Let's look at the answer because I'm a little stumped of exactly. Okay, so there's the answer right there. I don't want to scroll too far. Oh, you can't see it though. Oh yeah, you can. So that's apparently perfectly okay. So great. Oh, before I forget, if anyone's interested in this, you can actually get this book online as an ebook or a physical book if you really want a copy. But you can also just look at my code if you would prefer to do that. But there's not a lot of, like, it's very limited explanation, and Chris's writing is quite good, so you would miss out on a lot by not having the book yourself. Okay, so anyway, I think we're okay with the way we did this. It's a fold and not fmap slash partial function, but we could do this. We could just use fmap in front instead, and that would be totally fine, I guess. Like, it would do the same thing. All right, so this time we have 1, 2. And here we're gonna need, I think, folding A, B. We sort of already saw this example, so I think that this is right. That certainly does something. Whether it's the correct thing or not, it is yet to be seen. But we want to end up with 1, 2. And I'm pretty sure that that's what that will do. Yep, there you go. So it seems like a lot of what we're doing right now is more intuition than anything. Like, I'm just kind of using the, well, I mean, maybe it's actually understanding and not intuition, but sometimes I'm unsure if, ow, did you hear that? That was really loud. Okay, 1, 1. Well, it's loud in my head, I guess, but I crack my neck all the time. Probably shouldn't, but I do. What if we do folding? No, but that's a lens. So this probably is this _2 is the lens that takes the second object. So what we could do is folding this maybe? Oh, right, but we need to embed. So this would have to be list. Oh, right, but this is the structure. So we need a folded, I think. Folded dot. Okay, now is this the best way to do this? Could we just use 2-second? I think so. Yep. That's probably much clearer. Could we also folding second? I don't think so. No, I think we need folded 2-second. Let's try it, sorry. I don't think this will work because we're embedding another list. Maybe. Folding. We probably need that. No. So we're no, because this is a list. So this is to list of. So we actually don't have. We can't put lenses here. We want like folds here. So I think it has to be like 2-second. Yeah. So because after you write the folding, you're gonna end up with a list. And the folding second doesn't work because we're when we run the fold, we're embedding another list. So the folding, okay, let's put an example together. Wait, I thought I just had this working. Is the LSP freaking out? Or is this actually wrong? I thought we just had this working. Oh, it's not folding, it's folded. That would be, I could see how that would be tricky. Oh, you got it. All right, so if we had, for example, you 1 1, we could write to list of folding second. I'm pretty sure. Yeah. So the error is yeah. So if we did this, I think this will give us what we want. But so you see the difference here, right? We have this embedded in another structure essentially. So that's why you need to first do folded and then 2-second. Does this make sense? Yeah. So this is pretty cool actually. I like that we're coming up with questions and like seeing how it behaves. This is very fun. So you wasn't in the book. It was an experiment with chat. All right, so V is this one. Might be able to just copy and paste this. I'm taking too long otherwise. 1, 2, 3. So this one can probably be folding. Maybe well, this isn't probably a great example. What is from just? You mentioned from just earlier. I don't. Oh, it just throws an error. Oh, that's a dangerous function. So I feel like we should do the following with this to make it. Whoops, I'm doing it over here. We should use maybe empty list id dot folded. I think is probably the function we want. So give me, oh, a B comes first. That's the problem. So we want to say, well, let's, does this compile or no? Excuse me. Ah, wait. Okay, so folding would take A, B, C. That's the problem. So I first need to embed this in a list, I guess. Wait, it worked? Hang on. I thought I tried that. Folded. Oh, no, it does work. Oh, no, this makes sense, right? Because this is composing a fold with the lens. No, this should work. I think I was just freaking out. Or maybe I didn't write this. I don't remember. This should work. This should work. Because you're composing this as your fold. Right? Your fold ends up being well, we could type it out, but yeah, this makes sense. 2 second is essentially this lens. They should be equivalent. All right. So I feel like, what's the best way to do this one? I don't know. What if we just do folded? What does that do? I don't think it will do anything, right? That's what I thought. Seems to me like we first need to turn this into a list before we can do anything. So it's probably just, that's probably the play, right? And then that will give us that. And then we can do, Oh, sure. Wait. I don't think that would work because we're trying to undo that operation. Yeah, yeah, yeah. That would put them in a tuple. No, no, don't worry. I don't know if there's a like a more convenient function there. The question I have is, I was really expecting that. Okay, so we have here this. If we use folded, we can't use folded because we don't have. No, like if we do folded here. Wait, what? What does this do? Why does this work? There must be something monoidal going on here, right? Semigroup. So the default folded apparently just works with a list of just. Okay. Yeah, I mean, I guess that makes sense. I keep thinking about folded as just a list, but that's really not what's going on here. It's foldable. That's pretty important. That is pretty important. And this is again the same thing, right? It should just put the lefts together. I think that's the default for semigroup. Oh no, it doesn't do that. So is there a function? There you go. Yeah, it's a super fun book. I'm having a ton of fun with it. Because it's basically like little puzzles. So that's really good. This always trips me up sometimes, this folded, but it's because we're using to list of, right? So we're basically embedding this in a list and then flattening it and then flattening it again. But the sort of the flattening is a monoidal flattening, or well, semi-group flattening. It's not necessarily a monoid. These are in monoids, but they don't have to be. Oh, very cool. Yeah, there's like lens libraries popping up all over the place in a bunch of different languages. So I think like if you know a little bit of Haskell, it would be really convenient to learn how to do it. No one knows how to use it. Yeah, I don't do enough C sharp. So like, do you have type classes and stuff? Like, how do you deal with semi groups? Jumping ahead, but I noticed there's something like fold R of. Okay, no higher kind of types. That's what I didn't think so. There are a lot of operators and weird symbols, right? Like you need to know what this one means, or it can be pretty tricky. Okay, so we got W, X. Oh, I gotta put the result for W. Okay. Uh, Let's see here. Oh, and Wizard Stick is a sub too. Very cool. Did you get gifted a sub or did you just sub? I don't remember. Either way, welcome to whatever we are. The Haskell Learning Gang? The Functional Programming Weirdos? What do you guys want to be? I still don't know what we should be called. I was thinking that we should be like the classroom, like welcome to the classroom, but I'm not really a teacher. Like we're all students. Iodine. Hey, how's it going? I've seen you as a prominent contributor to Soding's chat, so nice to have you here. Right now, so like this whole, usually what I do on stream is like go through these books and try and learn stuff about them. So like on the stream so far, we've gone through Haskell programming from first principles, the type, what is it called? Thinking with types. We went through the book of monads, and now we're working through optics by example. We also did an Elm book, but we're done with that. And then I'm going to do another Haskell book here in a little while. That one's in like collaboration with Manning, so that's kind of cool. Not in collaboration, like I'm just going to do the book and they are probably going to put some stuff on their website about it. Maybe not their website, but somewhere. I don't know. We have some kind of affiliation with Manning. Like you can buy books in my name and it makes me a little bit of cash for this stream. Okay. Yeah, maybe I should call you the teachers, right? Like welcome to the teachers, and then just clarify that you're the teachers and I'm the student. What about that? Got through about 1,000 pages. Yeah, that book is intense. That's a very long book. Thanks for the follow, I think you pronounce it iodine. It might there's a lot of extra syllables in there, so I'm not entirely sure, but I'm going to pronounce it iodine because that's how I've always read it when I see you talking in Soding's chat. Yeah, that book is tough. I really wish I could have saved all the videos that I did and like the code, but the author asked me not to. Authors. So I didn't, which is unfortunate. Okay, so we got to get back to the task at hand. Yeah, we're trying to also get to the point where we can actually make Haskell projects, but you still need a lot of information after you get through those books to write professional Haskell. Well, I'm not going to comment on that, but it is a good book for sure. Okay, what are we doing? Right, so we want to basically 1, 2. Probably a much better way to do that, but I'm stupid, so don't worry about it. Okay, so we have a list of these funny tuples. Yeah, I think like pick a project that you want to do and then just do it in Haskell. It's going to be painful at first as you get used to it, but like it gets better. For example, like we started doing the effects systems, and I found that implementing the REST API after I understood the effects systems was actually not that hard. Like integrating, being able to do tracing, logging, read and write from your database, and other effectful things wasn't that hard. Readers and state, like we combine all those things together, and you can just do what you need to do, which is nice. All right, so we're gonna have to first folded, then we're gonna have to do folding, and we're gonna need to do okay, and then the question is, I'm kind of okay. That's how I feel about Haskell as well. Yeah, so you're further than I am. Yeah, monad transformers are pretty tricky, although it's mostly just getting the order right. Like once you have the order right, it's not so bad. And then lifting and unlifting is pretty tough. But the effect systems make that even easier. So, all right, so this should compile, I think. The question is, how many more foldeds do we need? So we're turning. We have list of list of list. So I think we need folded, folded, folded. Too many. Maybe it's only 3. Maybe it's not. What does this return? This compiled. I would have guessed that this performed like some interesting embedded folded or list structure. Nope. Oh, it does. I just had way too many. It should be just folded. I thought there would be more. Sorry. Yeah, there we go. I thought there was at least another level of nesting, but apparently not. Okay, so why is that? So we convert this to list, basically. So it's list of, okay, yeah, that makes sense. List this, then we combine them. So list, list. So that makes sense. Like I'm just being silly. I honestly thought we would need at least one more. But anyway, okay. So then we have this one. Oh, yeah, yeah. W. Not W. Y. Okay, and then fold R of. So my guess is that this is going to be list of 1, 2, 3. Yeah. So this each basically allows you to fold like a list over a tuple. So each, oh man, that actually, we might be able to use that here. Can you just do each? I'm just guessing. Ah, we need a structure. Yeah, I don't see how this is gonna work. It would have to be. I understand why it works for the fold of, but if we wanted to do this, we would need to really like, I guess, embed them in a foldable structure, which would be list. So we could do like a singleton, I guess. But we need singleton, so let's just not complicate our life. Ah, okay, that doesn't really do what I was expecting it to do. I was expecting something different. Anyway, let's not get hung up on that. But that's an interesting function. Okay, so what's the goal here? We've almost exhausted our alphabet as well. Left 1, right 2, left 3, right 4. Okay, so like odd numbers are lefts. So we're gonna have to do folded, folding, odd, yeah? What? Oh, too many folds. This should be 2. There we go. So because we were using folding, it basically created the either integers and then folded them. So we only got the rights out of it. But what we want to do is just convert them. So we use 2 instead, not folding. Hopefully that makes sense. And I don't know if there's a better way to write this function, but I can't imagine there is. I can't imagine there's an obvious way to write that function better. Maybe somebody will change my mind. Okay, so we got that one. That one was kind of cool. There's a lot of these. My goodness. Z. Alrighty. So this is kind of like this one. Ban. Wow. 3 of them. That's insane. I've never seen 3 of them. Bye. Usually there's like 1, but 3? My lord. So I guess we can do and I think this is just enough. I was like, oh no, I gotta ban someone else. Oh, wait, I did need that parenthesis. What? Look at the highlighting. Oh wait, no, okay. I thought I saw that. Anyway. So we're at Z? Yeah, okay. That's what I thought. I'm starting to get a feeling for the level of nestedness there. I guess we're on to the primes. A classic Haskell move. 1, 2. All right. So this one is interesting. This one's very interesting. I suppose there's something here about does this compile? What does this compile to? Oh, I'm so thrown off. How do we make this work? So we want all the justs and the rights. So we want to combine them. Oh, maybe we embed them in a... Can we do this? These are all the same, though. I think we need to do... This one's weird. I guess we just need to deal with them more specifically in here, right? Well, let's just put this down here and then go back to this, I guess. So in here, we just have to be more specific about the way we deal with A. So if... No. Maybe... But again, the problem is... No, because then we can't deal with this one. Oh, but the one will just go away. We don't care. So we're fine. So maybe... I think. And then either... I gotta look at the type again of either. We need a function for both of them to produce a C. So it can just be const empty list id. Okay, but this is complaining here. But what's the type of maybe again? So give me an empty list or an A to B. So this needs to be a colon empty list because we need to embed it in the list. It can't be like so. But this is now no instance for num. Like, you can see that it's looking at the right place, which is really interesting. Right, because the errors pop up on specifically the numbers. I'm sort of in the right place, I think. But why? Hmm. 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 That's not gonna do anything. Well, what's there? Yeah, no, it's the same error. No instance for num. List of A. What am I doing with num here? I'm very confused. Does that, like, what does this do? Do these really need to be specific? Yeah, that's what I thought. Because we have an internal... Wait. Okay. So, expected type. Ah, so this is the problem. Actual type. Either int, but it's getting either list of int. Okay. So something's wrong with my either. So A to C. So given a left, give me empty list. Given a right. Oh, that's the problem, is I have to explicitly ignore the left. I think. C. Ah, no, it's right there. I see it. I'm stupid. There we go. That should be right. And then apparently we can age limit this. Sure. Sure. This function is pretty awkward, but I think that this is right. We may need an additional folded, but I'm not sure. Yeah, we do. To be fair, I had that last time. Yeah, there you go. Okay, maybe? Let's look at, how's that foldar look that you had? I don't see how we were gonna do it with that. Because we can't do the same thing in both cases. Is it? Not really the same concept though. Because in the fold R of, you have like a tuple of the same type. And here we have two different types. Now, the one question is this necessary still? I didn't think so. And then we probably write a helper either to list. It's almost the same concept, but slightly different because we have to deal with the maybe and either specifically, I think. Maybe we'll find some interesting functions that he's got that we can work with. So we're going to have an either A, B, and what we want to return is a list of B, basically. If you have a left, just give me empty list. If you have a right, you want that, and then we can just use this, I think. Just to clean up the syntax a little bit. Because it did, I mean, it looks a little ugly right now. But anyway, this works. All right, let's do the next one. B prime. That one is a little, I find that one a little tough, actually. Because you're like, you got to deal with the two things differently. And I guess this is going to be similar, but easier. It's going to be a very similar looking one. It's like folded, folding. That one's much more straightforward, though. Cool. C prime. I doubt we have set in here. Oh, we do. Okay, wonderful. So we have a set, which I think just. Ooh, interesting. Cell. Okay. So we're gonna say folded. Oh, okay, so we need folded, I guess. Nice. That's not too bad. So actually, this one was kind of the hardest one because it requires a little machinery. The other ones are pretty straightforward, actually. Oh, I need to put the actual results here so people know. Left 1, right 1, left 2, right 2. I'll copy and paste this one because I don't feel like transcribing them backwards. And I'll do it wrong. Okay. So devise a fold which returns the expected result. Think outside the box a little bit. Okay. I'm into it. Hello? Yeah, some people were mentioning that. I think somebody mentioned that before, but I've never used it before, so like adding a new tool to my toolbox is already hard for me because I'm not very good at this. So is this just these things summed? Like I don't know what that is. 12, 45, 66, 91, 87. Multiplied? Uh, um, times 45 times 66 plus divided by 2. It's 100,000, so no. Middle ones from tuples in order. Oh, I see. I got you. I'm thinking like some math. It's a string. It's not a mathematical function. Thank you. I'm being stupid. Um, okay. So we need to first. Thank you, iodine. Do folded, folding. I should have paid more attention, apparently. I just assumed it was some sort of mathematical thing. So we don't need this one. We need this one. We need this. We'll embed this in a list, right? But we'll do it as a show. And we can also actually just do reverse show B folded, I think. I think this will work, but it says think outside the box, so maybe we should think outside the box. Maybe? Like this is very much not thinking outside the box. This is doing it exactly the same as we've done before. So what if we did folded to reverse dot show that's greatly simplified, and I think it's correct. But we're still not thinking outside the box. So what does thinking outside the box mean here? I really don't know. We'll see what he does. I mean, this seems like an answer. Should be able to use each. I don't think so again, because like we're trying to pull something out. Like if each would require us to need all of these tuple elements, I think. You really want to use each though. I don't know how you would use it here. Let's see what he does that's thinking outside the box. Maybe there's something clever that you can do that I'm just not. You fold on them, but then you still have to like ignore. It is the same type, but oh, I guess okay. I see. You're saying like we're doing each on both of these tuples, but that's not quite how each works. We can mess with it. Hang on. Let's see if we can get this done. Just don't know what thinking outside the box means. I mean, I guess I know what it means, but oh, interesting. That works. Interesting. I guess it's a predicate, right? So it does work. That's cool. Thanks, Hlet. Now the question is what is the result? No, it's just what I needed. Can I still actually send this to folded? Or no? Really? Really? I'm unsure what that error is coming from, but I should be able to combine strings. So anyway, not sure what that's about. Maybe I have to be specific that it's a string. Maybe if I do the following. And then do dot folded. Maybe that's. Oh, yeah. I don't need these brackets. And this works. And that should give me. Yeah, okay, cool. All right, I'm afraid to format this code because I think it's going to stick all of these onto the second one, but I would really like to format the code. But that's okay. I don't want to fix it, but maybe I should. I don't know. I think. Oh no, it keeps them down. That's good. Pretty interesting. We got all the way through to E prime. Okay, I want to go look at the answers to these because I'm mostly curious about the ones at the end and if there's anything interesting that he did that we didn't do. All right, that took us quite a while actually. I don't know if it's because I was just slow or we had a lot of different conversations. Yeah, we can start with the last one and work up. Bonus. Okay, so this isn't really outside of the box from the standpoint. Like this almost reads cleaner than that. So that's fine. Folded to. Oh yeah, so this is pretty short actually, so that's kind of cool. Okay, so thinking outside the box was not all that scary. I was thinking it meant more, but I think the rest of them are probably pretty straightforward. Excuse me. Folding reverse. Yep. AB. Okay, that one's not very interesting. This one might be interesting. Oh, that's cool. That's very cool. That's way better than our version. Cool. I like that one a lot. So we're going to stick an A double prime in here. Yeah, there might be like a newer syntax highlighter that would do that a little bit better. I'm unsure. Like I'm just using the default one, and I think, like Haskell Vim, and it's pretty old, so it might just be there might be better format or highlighters. Sorry, I'm trying to think about this while I write it instead of looking at the answer. Okay, so we have this A thing, so it's like and what does this return? Does this return the answer? It does. That's cool. I did not think about that. So basically what we're doing is we're making a query for all of these and combining them into a list. So folding is way more powerful than what I was thinking about. Yeah, this is pretty powerful right here. So like when I was doing these before, I was thinking, well, maybe this is a bad example or a good example. Is like this happens for every tuple, right? So we're querying all of these things to create a list. And in this case, we're creating basically a list of these and a list of these. And then what we're doing is saying, okay, convert those to a list and flatten them. So you'll have list of this. Yeah, I think I said that right. And then combine these with the semigroup operator. So you'll get 1 on this side, and then you'll get these two things reduced, which will just give you 2 in this particular case. So this is super cool. So you got to think about these more, like a little more clever. Like in my case, I just dealt with them, more or less manually, but like you can still combine folds inside folds. Very cool. This is a little tougher to reason about or think about, but like that's still really cool. So I should just make a note here. A double prime comes from the answers. Words. That's super cool. 363. Neat. Okay, let's see if there's any other brain busters in there. So that one's super neat. This one's pretty straightforward. I wonder if there's a way to do something like this in there. I don't see how you would do it because it's not like you're not like reducing, you're creating. It's like the what are those called? It's still a fold, but it's a, I can't remember. Somebody knows the name I'm trying to come up with. Yeah, so this is odd n, left n. Nice. That one was what we did. Folded, folded we did. What did we do here? I think we just embedded them in a list. 1, 2. Yep. So we just stuck them in a list and added a folded, but you can do it by combining them instead, and then you can ignore this other folded. So that's a good idea. You know, I just realized I did again. When I came back, I put these headphones in, and there's nothing in them, nothing playing on them. I do this all the time. There's no sound, like my stream doesn't make any noise, so at least not in my ears. So that was silly. Anyway. Yeah, it's like super common. Oh, nice. So we clean this up a little bit, right? Instead of, oh wait, no, this was you. This was an experiment. This one is folding too, but these are the same thing we figured out. Yeah, I always work with my headphones on, so when I sit down, I put my headphones in. Super obvious, right? All right, so I think the bonus was pretty easy. I think that this was the coolest thing that we got from here. I think this solution's really neat, and I wouldn't have thought about it, but it makes sense from our standpoint. Okay, so we want to go back to the questions. Need some more water. I think I'll probably do some more music listening to this weekend, so those headphones will actually matter. Hopefully we can keep working on our pure script stuff this weekend. We'll see. I got stuff going on. I'm gonna have a very complicated month. Very, very complicated month. So I'm gonna do my best to stream as much as I can. All right. Fold actions. Oh yeah, you gotta double down. Itchy. I don't remember if I'm putting the double dashes there. Okay, so we've already seen toList of. So toList of was the caret ... operator, which collects all the focus items into a list. But there are a ton of other actions we can perform on folds. Excuse me. These actions represent queries we can ask of our structures. We can use a fold to just select the parts of the structure we care about, then ask questions about it. Some questions we can ask: which focuses match this predicate? What's the largest element in the structure? What's the result of running this side effect on every focus? That's interesting. What's the sum? Does this fold focus any elements? Okay, so does the query return an empty list or something? So this is cool. It's like queries. A rule of thumb when looking for which action to use on a fold, think of the function you'd use on normal ol Haskell. Then add the suffix of. Need the total, sum of. Need the smallest, minimum of. Neat. Okay. Most of these behave as though you've collected your fold into a list and then run the respective operation, but they tend to optimize performance a little better. If you look at the actual type of sum of, endo, some crazy type. Okay, that's really useful. Like, just don't concern yourself too much with this and just think of it as a something SA. So it could be a fold or a lens. It's a lot of words. Let's look at some examples. Great. All right, so I think we're on E prime. Yep. Oh, I just want to do equals, I think. LM of folded 3. Wow, the order of this is kind of strange. So it takes a fold, in this case just folded. It takes an A and then checks to see if the A is in the fold. Or sorry, the A is in, yeah, I mean, I guess the fold. So in this case, folded is querying or focusing on every element in the list. And then we can use lm of to see if something is in there. The order is very interesting of the arguments. That's cool. Any. So are any of these true? Folded, even. Interesting. Okay, sure. Greater than 10, something like that. All of, sure. Makes sense. I'm not going to write that one in here. Find the first element. That's cool. All right, those are just true and false questions. I want to write this one down because I think it's useful. Hey Daniel, what's going on? Thank you for telling me to hydrate. I will. I think I've seen you on the stream before. Glad to have you back. One. Should just do 1.4. That would be faster. Oh no. We got a hydrate train. Thank you, Ida. Use your little helices. You can also use the emotes if you want. Depending on how much you have. I would, play with the emotes. They're stupid. My emotes are terrible. But I don't know what to do else. So it is what it is. Oh, nice. Yeah. Using the correct conjunction. I love it. All right, so anyway, this one returns nothing. Just the 2, true, true. Does my fold have elements or not? Has. Cool. So can we focus anything? That's cool. Has or hasn't. Those are functions we're not familiar with. So we'll write them. True. Okay. Just as an example to give us this. Length. That's cool. So I'm just gonna write these down. So length of sum of product of, like, I don't really need to put an example in here. I think we're starting to get the point. First preview. Interesting. First of preview. I like the name preview. This is like a flip, but that's fine. We can look at that later. Last of. There's no post view. There's a preview. Shouldn't there be a post view? Minimum of. Okay. Case study. Sounds fun. An aspiring TV show critic, incredibly comprehensive collection of facts about vast assortment of TV shows. Okay. Talk about TV shows. I see How I Met Your Mother, which is a show that I really enjoy. Although it's pretty, doesn't really stand the test of time, does it? TV show. TV show. Should just copy this, but the last time I tried to copy a multi-line piece of code, it really didn't go well. It puts a bunch of weird spacing and stuff. We might need these. Oops. Okay, and then this is gonna complain. I'm too lazy to solve this code, so we'll just use name in Spanish. We could do, we might be able to do duplicate record fields, but I have no idea how those behave with lenses. and I know enough Spanish to be not really dangerous, but I know what name is. Yeah. I don't speak a ton of Spanish. Like I couldn't hold a conversation with someone, but I know a lot of nouns. I learned Spanish like in grade school and high school, but I wasn't very good at it. And my my girlfriend is a native Spanish speaker, so start one. Oh yeah, yeah. I can't hold a conversation in Spanish. Um, I can understand a lot of words, but I can't speak at all. Like when um I'm in a room full of Spanish speakers, I can usually catch like what they're talking about, but I can't follow the conversation. So anyway, it is what it is. Oh, I do not want to type all of this. My goodness. Please allow me to copy and paste this code in not the worst way possible. Yeah, see, this is what it did last time. All right, so this can go here, and that can go there. That goes away. This goes over. This goes over. That goes over. And I think these are the actors. So we'll put them there. Now, what is this? Most verbose Haskell. I mean, it's just like they're data structures, so like there's not much we can do about it. Okay, so TV show. It's interesting to me how. Oh, and then we need to. How do I? Can I do like? Oh hell yeah! Well, I don't want to do it down here, but to be fair, I didn't know I could do that. That's pretty cool. Okay, this should compile. All right. Your Haskell is pretty good. I didn't do any Haskell there. That was all Vim. Why is it not putting spaces there? That's very strange. Do you see that? What is it doing? Okay. Good. So now we got some data structures there. And we'll keep going. Is this impressive? I mean, I guess so. Most of this is Googleable. I know these names because I watched How I Met Your Mother, but I've actually never watched Buffy. Oh, that's interesting. I didn't realize she was in this as well. So, we got an Allison Hannigan fan here. Anyway, never seen Buffy. Is Buffy worth watching? Anybody seen it? I know it's about vampire slaying. All right. So, we're going to practice. What number are we on? Letter number. Yeah. Yeah, so I do work in research. Specifically, I'm working on machine learning applied to ecology currently. Okay, so let's think about this. But like the research I did in graduate school was all chemistry based. But I haven't done any chemistry in quite a long time, unfortunately. I'd like to get back to that stuff on stream sometime. I'll get there eventually. I feel confident in my Haskell abilities. Oh, and I have enough time to actually spend on reading this book behind me. But this, you think FFP is big? Like this book. That book? Actually, it's less pages. It just looks big because the font. It's like 900 pages. Yeah, 880 pages. But this is dense. It's much denser than HPF from an intellectual standpoint. Oh yeah, so are you asking what deep learning is, just to make sure I'm clear? All right, so what is this doing? So we're going to take the number of TV shows, we're going to fold over them, focusing on the number of episodes. So our first focus is these guys. That's what the folded does. Then our second focus is the num episodes. And so we should get back 144 plus 208, I guess. Yeah. Yeah. Daniel, just feel free to just clarify the question and I'll gladly answer it. But I mean, the answer to what is deep learning is quite complicated, and I don't think I'm the appropriate person to answer that question. I'm more of a user than a teacher, although I'm trying to learn like all the requisite mathematics to teach folks deep learning, but it's going to take some time. It's basically all linear algebra, but like the implementations are a little more complicated. Okay, so sure, this makes perfect sense. Yep. To aggregate, very cool. Okay, so oh yes, yeah, okay, great. That makes more sense. Yes, I use deep learning at work. So like part of my job is to be like a data scientist. So I try and help people do deep learning on our cluster. So I also do deep learning research with some people at the university. Is he doing the I recognize that name for sure. Is he doing the Hask torch thing? Or is he doing something else? I don't know what his name is on here. It might be something else. What is there? Grenade? There's like a bunch of different. How do I pronounce this? Is it Hugh? It can't be. Might be. Yeah, I mean, let me know which one it is, because these are the two that I'm familiar with, but I think there's probably another one. I think Haskell would be a really cool language to write write deep learning stuff in. I've seen better as well. This is pretty neat though. What if we want to know which show actually has a score? There's another action called maximum by of, which allows us to score parts of our fold by comparison function, just like maximum by. It takes a fold, a comparison function, and a structure. Oh, he has a talk on YouTube? Okay. I will check it out. That sounds interesting. Hmm. Okay, so what does O produce? It must produce a TV show? Okay. And then they're mapping. They're just pulling out the title. What if we just do what's the lens for just? I'm kind of interested. Is it just underscore? Ow. I feel like I've seen Jappy specifically use a lens for just. Like specifically for just. But maybe you can't do that? Because this won't compile. Because there's a prism. Ah. I don't know enough about prisms, but what if we just try it? Okay, it just works. Fun. Also, hi Ken, how's it going? So I guess this should do what I want it to do, but I don't, well, it's sort of different than what they're doing here, but we'll pretend that I know what a prism is. So what if this doesn't yield anything? Does it just ignore? Like returns nothing? How does it work? I guess we need to learn about prisms to understand why it works. So let's not go into that. We'll just use starting to compile slow. Yeah, but this doesn't say just, which is interesting. That's why I thought it was interesting. Because, like, you use the prism just, but you get back a string. You don't get back just string. That's why I thought it was weird. It's not that important, but We're gonna learn about it here in a bit. Probably. Yeah, it just seems a little strange. Like, how does that compile? Like, what happens when there's nothing there? Can we? How would I test it? Can I just do nothing? Oh, it's got to be a monoid. So there has to be a mempty, basically. So yeah, so prisms must require a monoid, I guess. And if we look at the type of just, we'll see choice and applicative, and one of these must require choice. Profunctor? Applicative? Applicative doesn't require a monoid. Oh, but it might require for something inside lens. It's not clear to me. I don't see it. Anyway, we'll learn about prisms. Or you do. Oh, that operator means first, I think. Like the prefix or something. Or you do. Could you give me an example of what you mean? I'm not exact. How? Because I think that means. I think that operator means first of, essentially. Oh, I see what you're saying. So, like, we're looking for something. We get nothing. But that means folded, I guess? Is that what you mean? Something like this? That would give me nothing. So in this case, we could do... Mm, on this one. Well, I suppose that's the same as view in this case, right? Oh, it's not. Interesting. Very interesting. This is a special type of monoid. Cool. Ow. I guess we'll learn more about this when we get to prisms. It's not really ow, by the way. It's fine. Kind of just a reaction for your body making funny noises. Yeah, eat dinner. I hope it's delicious. I had tacos tonight. They were delicious. Okay. Should that. Okay, so focus the TV shows, focus the actors, focus the actors, these actors, like the list of actors. Default value. Yeah, exactly. So it's like the view or the caret dot gives you mempty on nothing, whereas the caret question mark is apparently using a specific monoid called first, and the first monoid either returns the first thing in a just or maybe or nothing. So it returns like a maybe of the first monoid, I guess. To be fair, I'm guessing based on the behavior. We like when we learn more about prisms, I think it will become more obvious probably. And I think that's actually the next chapter. No, we're almost to prisms. So hopefully when we learn a little bit more, that'll be useful. Okay, so this makes sense to me. Like I can read this more or less as a human being, and I think I'm starting to feel how you're supposed to think about the folded function, right? Like how you view it, for a lack of a better term, right? All this is doing is providing a focus, and it's providing multiple focuses. Foci? Is that the plural of focus? I think it is. So it's like you're going to start with your TV shows. So first, we're going to focus the elements in the list. Then we're going to focus the actors. Then we're going to focus the actors inside. The actor. Yeah, actors, then actor. And then we're going to compare these by their birth year. And we want the minimum birth year. So we should get 1954, I think. 1954, Anthony Head. I don't know who that is. I probably do. Okay, now I need to look him up. There's so many references I have to check in here. Yeah, okay, I know who that guy is. Okay. It's still a bit annoying to specify the comparator as a function rather than an optic, but it's easy enough to fix. We can write a new combinator which solves this for us. Comparing of accepts a lens and will return the sort of comparator function that actions like minimum by of expects. Is this a typo? Return the sort of comparator function that actions like minimum by of expect. No, because I read this as action. I think this is the first time we've passed an optic as an argument to a function we've written ourselves. Optics are just values. We can pass them around to functions if we like. Let's see an object-oriented language do that in dot notation. Ooh, shots fired. Okay, so we can write a function. Well, let's just put it down here. Comparing of chord A, lens, SA, S ordering. How's comparing look? Okay, so a function that converts a B to an A and two B's. So this could just be comparing the other way, isn't it? No, this is still complaining. Oh, ranking. Okay. Sure. So view L takes an A. So I think it is this way. Yeah. Okay. I wanted to make sure I was doing it right. Cool. We don't need to do that, but it's just because I'm trying to get used to the operators. So I want to make sure I'm thinking about this right, because the left side, the thing that we're going to be operating on, will be a structure. So I need to take an S to an A, which is what this L will do, and then I can use the comparing function to take two A's that are ORed and just compare them. And then we can rewrite P as comparing up. Yeah, that would probably work. Maybe. It's close. So the first argument will take that. I think it's just this. No, because then I need to take two other arguments. So it's actually like double Blackbird. Right. Let's put it in the tool. Oh, even simpler. See, Daniel? Yeah, because we just need to take L and then I mean, I wouldn't write this. I don't think. Like, I would just write this. I mean, really, what I would write is view L. But flip view, I mean, we could write that. Actually, there is a flip view function, isn't there? I think there is a flip view function. Let's go look. view. There might not be. There's a flip something function that was useful. I don't remember what it was. But really, we should just write this as view. It would be a lot better. Okay. Do we check that this works? I mean, I'm not concerned about it not working. Folding with effects. Okay, so we're gonna stop here, I think.